So the first column would be the symbol for the isotope. Next one we can just write in the name. That will be really easy. The third one is called the atomic number. And the atomic number is represented by the number of protons, which is that one I gave you to identify the elements you had to study. So it's always a whole number. It's always, remember, protons cannot be lost or gained by the atom, so it's always constant. This here, the column here would be mass number. So that column will have to be given to you, or you'll have to be given enough information that you can calculate it. It's really easy to calculate too. Okay, we're just adding and subtracting. This column would be protons. Then the neutrons, again, we're going to have to calculate that if we're not given the number of neutrons. All right? And the electrons will be pretty easy to determine because it will be the same as the protons if it's neutral. So if you got an atom that doesn't have a charge, we say is neutral, which doesn't happen very often. Most elements on the periodic table are never found in that form. They always have extra electrons or fewer electrons. They're never, very rarely are they going to be pure, where they are exactly the way they are on the periodic table, with the same number of protons as electrons. Okay? Many times they went through a process of losing or gaining electrons. And then the last column would be what we have for charge. Okay? So let's go through and fill this out and see if we can take these numbers. And this is really all we need to do to fill it. We don't even need the periodic table to fill this column out. So if we have these isotopes, carbon with 12/6 and the other carbon with 14/6, we don't need to look at the periodic table. Okay? Because you guys know your names now. So C is carbon. Atomic number, what would it be? This is atomic mass, remember? So it would be, it's always the lower number. And if you forget, look at the periodic table, and it'll tell you what it is. So it's 6 for both. So both of them have, see, the atomic number identifies the element. So both of these are isotopes of one another, but the number, atomic number, identifies the element, and if it has 6 protons, it's always carbon. No matter how many neutrons, how many electrons it has, it's always carbon. The mass number, what would that be? 12 and 14. So that's really easy because that's with the neutrons added in to the protons. So that would be the addition of the neutrons to the protons to get you that number. And that's in the nucleus, right? So the protons match the atomic number. So these two, atomic number and protons, are synonymous with one another. They mean the same thing. Protons, atomic number, same. So it's 6. Kind of repetitive, all right? But we use atomic number quite a bit, identifying elements in that instead of saying protons sometimes. So now the neutrons have to be added to the protons to give you the mass number. So how many neutrons do we have in the first one? 6. Okay, so these two, protons and neutrons, they need to add together to get you your mass number. And so this one would be how many?
8.
8. Okay, there's no decimals on these. They're all counting. They're all counts. Now, there's no charges on these. All right? Now, I don't see anything that says a negative or positive charge on these anywhere. There might be down here. We might show some charges down below. But these we're not showing any. So if that's the case, how many electrons are there? There's 6 and 6. See, they'll be the same. And then so the charge, of course, we know is 0 because they match up. They match up, then there's no charge. So the next one is no charge. Why don't you see if you can write with the information that I gave you, why don't you see if you can fill in all those slots on the third row across. See if you can fill it in, and we'll see how close you are to what it is by filling it in. All right? So do we have it filled out? What element is that? Zinc. Zinc. Okay? What's here would be, well, let's not fill in this one till the end. Okay? Maybe you got it filled in already. That's fine. So what's the atomic number for zinc? 30. We figured out it was zinc not by the 65, but the 30, because that's the atomic number, and we look the atomic number up, and it's zinc. The number of neutrons, how many would that be? 35, because we know that when we add, we take away 30, which is the protons, it leaves only neutrons behind, and there's 35 would be left behind. So 35 and 30 is 65, and that's the neutrons. And then the electrons would be 30. So we haven't really challenged you on the charges yet. So then that would be Zn, and then up above I'd have 65. Down below I'd have 30. And that's what you would do. Now, we'll do the next one together because we've got this -3. But that's only going to affect, that -3 will only affect this box. Okay, that's the only thing it'll affect is this box. So we can fill everything in except for this last box. So let's go ahead and do that. So what element is it? Phosphorus. Okay, well, we won't fill in this either. Next to last, we'll fill that one in. So, what's the mass number? 31. And you got that because you took 15 plus 16 is 31. So, neutrons, protons, 31. Okay? And so, we're good with that. So, we can come over here and we can put our P. And then what we can do is we can put 31 above and 15 down there. And now we have to determine what goes in this box. So let me tell you about the -3, why it's a -3. Okay, we know electrons are negative. We know protons are positive. So if we have a -3 there, how do the electrons and protons compare? There's more electrons than protons. Because there's more of these making it a net negative charge. Some students miss this one because they think the protons change somehow, and they don't. It's only electrons. So we don't, a lot of times negative means losing. But in this case, it's not losing. Because if it lost negatives, that means it would be positive. So it's gaining free electrons. So how many electrons do we have? 18. Okay? Because we can look, protons 15, 18, we've got 3 more negatives, so that's what it's going to be. So over here, what I would do to show that it has a charge, I would put in the upper part of it, I'd put a -3. So that kind of shows the charge of that isotope. So go ahead and do the last row across and see if you have everything filled out like the one above. And then your assignment over the break would be page 127, number 70. So page 127, number 70. We'll do this one here real quick. Go ahead and fill it in. And that's pretty much all you need to do when you're dealing with counting isotopes and looking at electrons and protons and how they compare. So take a minute on that last one, and then we'll see what you get for an answer. Mm-hmm.